Python is a general purpose programming language that is becoming ever popular in the data analytics industry. So companies worldwide use Python to harvest insights from their data and gain a competitive advantage. So welcome back to the channel and welcome back to Excel Island, where the goal and objective is to learn and master Python over the next 100 days. Today is day 11. So we've started this Python learning journey a couple of days ago. 10 days ago, actually. So we are on day 11, and we've covered quite a lot in those little period of time. Not quite a lot. You can easily catch up on all previous lessons and live stream when you go to the live stream tab on the channel. And you can easily check the comment section of this video. I will pin all the previous lessons so you can easily catch up from day 1 all the way to day 10 under the comment section. I'm going to pin it so you can easily find it and catch up with me. So we are currently on data analysis with Python career track on the DataCamp platform. We are on the second course, which is intermediate Python. We started with introduction to Python, where we actually covered Python basics, just like data types, variables in Python. We also covered Python lists. We also covered functions and packages. Then we got introduced to the first function or package in Python, which is the NumPy package. So that was what we did at least for the first couple of 5 days, from day 1 to day 5 actually. Then since then we moved to intermediate Python, where we started with matplotlib for data visualization. We did dictionaries and pandas for tabular data structure, how to create dictionary, how to create pandas, and how to use pandas to extract insights from your tabular data, so just like your normal CSV files, table, rows and column data structure. So we've covered quite a lot over the past couple of days. So today we are moving to what is called logic, control flow, and filtering in Python. So we want to learn about the various operators, how you can combine Boolean operators, and how to use Boolean outcome in control structures. So basically, we want to learn all about control structures in Python, which is logic, control flow, and filtering. So also all the CSV files, the data set to be using all for this learning journey is already linked under the YouTube description. So do make sure to download those files and practice along with me. So without further ado, welcome back to the learning journey and welcome to day 11 as we continue our Python uh, challenge also. So the idea is to spend at least an hour, not at least exactly an hour on each live stream, so we won't be too overwhelmed with knowledge. Because some of the lessons on this Python career track, they are quite huge. They are quite the content are quite high, so you can't just easily cover all of them in one sitting, or else you just forget the knowledge. You just go off unexpectedly like that. So let me just move over to my DataCamp platform. If I go under the career track section real quick, so you could see what we have here. You can see we are on data analyst with Python career track, just 16% out of the whole career track. So when this fun way of learning actually started, it all started with data analysis in SQL. We did that for a 100-day period. Then we also covered data analysis in Power BI for at least I actually spent 69 or 70 days on this. So you can catch everything. Just go to the live stream tab on the channel. You'll see the data analysis in Power BI career track also, where we covered it for over 60 days of learning. Then we also did the data analysis in SQL. That was the first idea that started this whole fun way of learning. We did that for a 100-day period also. All the videos are on the live stream tab on the channel. So let's continue with our data analysis with Python. So we're definitely moving to intermediate Python. So we've covered matplotlib, we've covered dictionaries and pandas. Now we are moving to logic and control flow in Python. So you can catch all of this on the live stream tab of the channel, as I said earlier. So do not forget to download the files, the CSV files under the YouTube description. So let's continue from here. So you'll be using our Jupyter notebook from Anaconda. I know when you download Anaconda and install Anaconda, you have access to all the Python environments and all other environments that you can use to practice Python. So I just launched my Jupyter notebook all the way from here. So if you want to learn how to install this on your computer, you can watch day 1 of this live stream. I actually recommended a video for you to watch by Alex, the data analyst. So he made a video on his channel walking you through how to install Anaconda Navigator. I'll just go to my download files, my DataCamp resources, and Python for data analysis. So this is the folder I'll be using. So this was what we learned on just 23 hours ago, how to use square brackets to access our pandas data frame. You see, so all this has been covered. We also learned all about lock and iLock and how to use it to extract certain rows, certain columns from your data, tabular data structure in Python. So let's move to comparison. So the whole idea, you could see that this logic and control flow and filtering, the content is quite much. If we were to cover it in one sitting, we'll be spending up to 3 hours there. So I'm just going to break it down into 3 or 4 live streams, minimum of 3, maximum of 4. Let's see the few content we could cover today. Probably all the way from here to this Boolean structure, if it is not that technical yet. So let's continue. And I would love to, okay, let's go on first.
Welcome back, budding Pythonistas. You've already learned a bit about different Python types. Among those was bool, short for Boolean. Do you remember the BMI array from the intro course? Here it is again. Using the greater than sign, we could find out which values in BMI were above 23. Next, I used the resulting Boolean array to actually select that value. In this video, we'll dive a little deeper into the world of comparison operators, like this greater than sign. Comparison operators are operators that can tell how two Python values relate and result in a Boolean. In the simplest sense, you can use these operators on numbers. Say, for example, that you want to check if 2 is smaller than 3. You type 2 less than sign 3 and hit enter. Because this is the case, you get true. You can also check if two values are equal with a double equals sign. From this call, we can see that 2 equals 3 gives us false. Makes sense because 2 is not equal to 3. You can also make a combination of equality and smaller than. Have a look at this command that checks if 2 is smaller than or equal to 3. It's true. But also, 3 smaller than or equal to 3 is true. Of course, you can also use comparison operators directly on variables that represent these integers, like I did in this example. All these operators also work for strings. Let's check if Carl is smaller than Chris. According to the alphabet, Carl comes before Chris, so the result is true. Do you think that comparing a string and an integer can work? Let's try to see if the integer 3 is smaller than the string Chris. Oof, we get an error. Typically, Python can't tell how two objects with different types relate. Different numeric types, such as floats and integers, are exceptions, as this example shows. No error this time. In general, always make sure that you make comparisons between objects of the same type. Another exception arises when we move back to the example we started with, where we compared the NumPy array, BMI, with an integer, 23. This works perfectly. NumPy figures out that you want to compare every element in BMI with 23 and returns corresponding Booleans. Behind the scenes, NumPy builds a NumPy array of the same size filled with the number 23 and then performs an element-wise comparison. This is concise yet very efficient code, something data scientists love. Have a look at this table that summarizes all comparison operators. You already know about some of these. They're all pretty straightforward, except for the last one maybe. The exclamation mark followed by an equal sign stands for inequality. It's basically the opposite of equality. Now, head over to the exercises and train your comparison skills.
Okay, those are quite straightforward comparison skills. Before we start, I always love to create my own Jupyter file notebook. So I will just go to We are intermediate Python. So we've learned all about matplotlib and dictionaries and pandas. So if you want me to give you access to these files, but I have these data sets, these bricks, these CSV files underneath the description, so you can download it from there. We want me to give you access to these Jupyter Notebook files, do let me know in the comment section and I'll upload it to the drive also. But I just create a new file for my control flow, filtering, and so on. Let's create a new notebook. So we're going to call this new notebook. We are on logic, control flow, and filtering. I'll just name it that logic. Okay, logic. Hold up. Logic, control flow, and filtering. You have it. So I have my files. What I always love to do is to get this my packages, import all of this. Let me just copy this. 'Cause we may probably just need it or we don't. But so you just import those packages there in case we are going to be needing them. Most of the time you need packages before you can start or manipulating your data. Okay, so equality sign. To check if two Python values or variables are equal, you can use this equal sign. To check for inequality, you need exclamation mark with an equal sign. So as a refresher, have a look at the following examples that all result in 2. Feel free to try them out. 2 is equal to 1 plus 1. Definitely true. Intermediate Python is not equal to Python. True is not equal to false. That should be true. Python is not equal to Python. That should be false. Now, when you write this comparison in a script, you will need to wrap a print function around them to see the output. Okay, because of this IPython shell here, if you are using our Jupyter notebook, you don't need to wrap it in a print. It should work fine. Write code to see if true equals false. Comparison of booleans. Okay, want to write if true equals false. So you could just say true equals false. Let's see. Comparison for integers. Write Python code to check if -5 times 15 is not equal to 75. Is not equal to. So open brackets -5 times 15 is not equal to. So we have to use the exclamation mark first. Not equal to 75. Comparison for strings. Ask Python whether the strings, PyScript and PyScript are equal. Okay. The first PyScript is starting with a small letter p. PyScripts and PyScripts are equal. Double equal sign. And the PyScript with a capital letter P. PyScripts. Okay, you can see the S is also capital letter there. Okay, the last one is say, what happens if you compare booleans and integers? Write code to see if 2 and 1 are equal. They're both equal. Well, for this scenario, we need to have them in print because of the interface we are using here. But let me copy this code first. Let's try it in Jupyter Notebook. I'll just paste it here and see. Let's run that. All of them are returning true, which is not fair. We want each of them to return different results. So I'm just going to copy it separately. Let me run this code first. I say 2 is not equal to false. Minus 5 times 15 is not equal to 75. That's correct. What about this? Oh, comparison of script. Pi script is equal to pi script. That should be false. Then the last one says compare boolean with an integer. 2 equals to 1. That will be true because 1 also means 2 in boolean operator. Now let's say it's in action here on DataCamp interface. I'm going to wrap it with prints because of their design of the Python shell, that the environment they have created here. So we're expecting we're expecting false 2, false 2. Let's run the code. And so we're expecting false 2, false 2. So we nailed it. Great. So the last comparison worked because the last comparison worked fine because actually a boolean is a special kind of integer. True corresponds to 1. False corresponds to 0. Yeah, we all know that. So greater than, greater and less than. So in the video, Google also talked about the less than and greater than signs. This, we're all familiar with all this in Python. Sorry about that. So you can combine them with an equal sign. Pay attention, is valid syntax, but this is not. So if you want to combine them with an equal sign, so the greater than is going to come first, while the equal sign follows, and the less than is going to come first, while the equal sign follows, not the other way around. All Python expressions in the following code chunk evaluate to 2. 3 is less than 4, correct. 3 is less than or equal to 4, correct. Alpha is less than or equal to beta, that should be 2. Remember that for string comparison, Python determines the relationship based on alphabetical order. Okay, so write Python expressions wrapped in a print function to check whether x is greater than or equal to minus 10. X has already been defined for you. So this is x. Okay, x is greater than this x. That's x is greater than or equal to minus 10. Why are we going to write it now? Okay, we should write it under here. Comparison of integers. So x is equal to minus 3 times 6. So to write a Python code, say x is greater than or equal to. So greater than or equal to minus 10. Should be minus 10. So we're going to wrap this in points. I'll have to copy this first. Okay. Test. Test is less than or equal to y. Why is it being defined for you? Tests. Okay. Test is less than. So the string tests. Test is less than or equal to. Oh, this place I was using less than here. I was also using greater than here. So less than or equal to y. So we have y there. Why the final one is 2 is greater than first. 2 is greater than first. 2 is greater than first. We know the answer to that already, but let me just copy this. Let's test it out in our Jupyter notebook. So I'm going to cut this part out. So let's run this code. We know that x is equal to minus 3 times 6. So we now say x is greater than or equal to 10. That's false. This also. Y is equal to test. So test is less than or equal to y. That's 2. Y the final one should be comparison. We all know this is false already. This is 2 here. Comparison 2 is greater than false. That is 2 rather. Now let's test it out. So we're expecting false 2 2. So it should be false 2 2. Let me repeat this in print in this section. Print. Print. Let's repeat in print right here. And finally, this one also in print. Okay, let's run the code. I see false 2 2. As expected, false 2 2. Let's submit the code. Great job. So this is a simple comparison. Okay. So let's see if we can get to the advanced state now. Compare arrays. Ooh, now let's compare arrays. So out of the box, you can also use comparison operators with numpy arrays. Remember areas. So the list of area measurement for different rooms in your house from introduction to Python. This time, there are two numpy arrays, my house and your house. So they both contain the areas of the kitchen for the kitchen, living room, bedroom, and bathroom in the same order. So you can compare them. Okay, we have my house, and your house. Okay, so my house greater than or equal to 18. So use comparison operators, generate Boolean arrays that answer the following questions. Which area in my house are greater than or equal to 18? Okay, which area in my house are greater than or equal to 18? Which area in my house? So you can just say my house are greater than or equal to 18. You can also compare two numpy arrays element wise. Which area in my house are smaller than the ones in your house? Okay, my house less than your house. Which area in my house are smaller than, that would be less than the area in your house. Okay, make sure to wrap both commands in a print statement so that you can inspect the output. But let's copy this and use it on Jupyter Notebook first. Okay, okay, since we have it here, now the variable above there. So we define the variables. So those are our variable. Now first of all, say my house greater than or equal to 18. Let's see. As we have 2 2. This is 18. For my house here, this is 18. Equals to 18 is 2. Greater than 18, this 20 here. This less than 18, this less than 18. So that should be correct. What about comparing both? You can see my house less than your house. 2 false false 2. You can see this is 2 less than, this is 18, is greater than 14, so it should be 2, not false here. Interesting. So these are simple, easy, straightforward comparison. Now let's add it in a print function here and run the code also. We are just less than 30 minutes into the live stream. Let's see that in action. Now let's run the code. You can see true, true, false, false, true, false, false, true, 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 false, false, true, false, false, true. That's super straightforward, eh? Ooh, print my house is less than your house. That's how I wrote it though. Oh, greater than. Oh, it should be greater than. My house less than your house. It should be greater than. Okay, I wrote less than. Oh, less than. I was using greater than there. Okay. I was using greater than, not less than. My house is supposed to be less than, not greater than. That's should be correct right now. Good job. It appears that the living room and bedroom in my house are smaller than the corresponding areas in your house. So let's move to Boolean operators. So let's cover these other parts, these few parts here. So come to the end of the live stream and continue the if else if part tomorrow live stream. Okay, let's learn something new again.
You're doing great. And now that you can produce booleans by performing comparison operations, the next step is combining these booleans. You can use boolean operators for this. The three most common ones are and, or, and not. The AND operator works just as you would expect. It takes two booleans and returns true only if both the booleans themselves are true. This means that true and true evaluates true, but false and true, true and false all evaluate to false.
False.
Instead of using booleans, we can of course use the results of comparisons. Suppose we have a variable x equal to 12. To check if this variable is greater than 5 but less than 15, we can use x greater than 5 and x less than 15. As you already learned, the first part will evaluate to true. The second part will also evaluate to true. So the result of this expression, true and true, is true. This makes sense because 12 lies between 5 and 15. The OR operator works similarly, but the difference is that only at least one of the booleans it uses should be true. This means that true or true equals true, but that also false or true and false or false results in false. Also here you can make combinations with variables, like this example that checks if a variable y, which is equal to 5, is less than 7 or above 13. 5 is less than 7 is true. 5 greater than 13 is false. The OR operation thus returns true. Finally, there's the NOT operator. It simply negates the Boolean value you use it on. Not true is false, not false is true. The NOT operation is typically useful if you're combining different Boolean operations and then want to negate that result. You'll see some examples in the exercises. Now, for NumPy arrays, things are different. Retaking the BMI example from the intro course, we can try to find out which BMIs are higher than 21, but lower than 22. The output of BMI greater than 21 is easily found. So is the one for the BMI lower than 22. Let's now try to combine those with the AND operator I just introduced. Oops, an error. The truth value of an array with more than one element is ambiguous and clearly doesn't like an array of Booleans to work on. After some digging in the NumPy documentation, you can find the functions logical and, logical or, and logical not, the array equivalents of and, or, and not. To find out which BMIs are between 21 and 22, we thus need this call. Again, as we expect from NumPy, the AND operation is performed element-wise. True and true gives true. Like these ones. But false and true, or true and false, gives false, like for these elements. To actually select only these BMIs from the BMI array, we can use the resulting array of Booleans in square brackets. Again, NumPy wins when it comes to writing short, yet very expressive Python code. I can hear you asking, cool, but how does this work for pandas data frames, the de facto standard for dataset manipulation? That's something you'll find out later in this chapter. First, try to ace the exercises that follow, and I'll see you in the next video.
Okay, now let's use Boolean operators with the NumPy logical functions to solve some of these challenges. Interesting. So and or not. So a Boolean is either 1 or 0, true or false. So with Boolean operators such as and, or, and not, you can combine these booleans to perform more advanced queries on your data. So in this sample code, two variables are defined, my kitchen and your kitchen, representing areas. Okay, we have my kitchen 18.0, your kitchen of 14.0. It says write Python expression wrapped in a print function to check whether my kitchen is bigger than 10 and smaller than 18. Ooh. Now let's see how we can combine that. My kitchen is bigger than 10 and smaller than 18. You can say my kitchen greater than 10 and less than, and my kitchen, you have to mention my kitchen less than 18. Okay, that's the first code. So my kitchen is smaller than 14 or bigger than 17. Or operator here. My kitchen is smaller as less than 14 or my kitchen or bigger than my kitchen greater than 17. Now let's say double the area of my kitchen is smaller than triple the area of your kitchen, or double the area of my kitchen. So my kitchen times 2 is smaller than, less than, triple the area of the kitchen. Your kitchen your kitchen times 3. Now we need to wrap all of this in quotes. Okay, but this is supposed to be in bracket first because of the multiplication. Now let's wrap this in multiplication too. But before I run the code here, let's test it out in Jupyter Notebook. So we define our kitchen here. So we have my kitchen 18, your kitchen 14. Now the first code to test is my kitchen bigger than 10 and smaller than 18. So my kitchen is greater than 10. That is false. And my kitchen is less than 18. That is true. No. My kitchen is greater than 10. False. My kitchen less than 18. False also. We're expecting false, false. Yes, false, false. We're supposed to return false, false. Probably, I don't know why it's not returning, but you see the same thing. Now let's test the second code. The second code says my kitchen smaller than 14 or bigger than 17. My kitchen is less than 14. That is true. Or my kitchen is greater than 17. That is false. So either of the, it's going to return either of the equation. It's returning the first one. So what I'm going to do now is, okay, since the and is there, I don't know why it is not returning. Let me paste the last one further. The last one here says double my kitchen. My kitchen times 2 is smaller than triple your kitchen. Let's see. That's 2. So my kitchen times 2 is this. This times 3 is smaller. Yeah, this should be smaller than 3 times 14. That should be 2. So let's see it in action here on the DataCamp platform. Okay, let's see. Let's see. Let's grab this in prints. Let's run the code. You can see false, true, 2. So it's even returning just one result, which is false, false, true, true. So we nailed it. Pretty straightforward, eh? Good job. And or not part two. Okay, we still have one more. And or not. Then we have Boolean operators with NumPy. Okay, it says to see if you completely understood the Boolean operators, have a look at the following piece of Python code. X is equal to 8, Y is equal to 9. Ooh, this is kind of tricky. We have to break it out or break it from the inside to the outside. What will the result be if you execute these three commands? And be notice that not has a higher priority than and or. It is executed first. Ooh. So let me just copy this. Yeah. Now let's try it in Jupyter Notebook. So x is 8, y is 9. Okay, those are the variables. It now says, hold up. X, we'll start from the inside. X is less than 3. That is 2. Because x is less than 3, yeah? Oh, that is false rather. So that is false. Y, this is going to return false. This one here, this first part here, I'm just going to copy this here. I don't want to run this code yet. I'm going to copy this from here. Control C, paste it here. X is less than 3. That is false. False, right? Now this other part here, Y is greater than 14 or Y is greater than 10. Let me copy that also. I see Y is greater than 14, 2, or Y is less than 10. Is greater than 10. This is false. But one is going to proceed this with that, which is false. Because Y is greater than 14. Y is 9 here, so this is false. So both of them is going to be false. Or Y is greater than 10, so it's going to be false. So this one now says, when we now add not to it here, X is not greater than X is not greater than, let me copy this and see from here. X is not greater than, is not less than 3. X is not less than 3. That's false. That should be 2. Yeah, that's 2. X is not less than 3. Because X is greater than 3. That's 2. Now, the second not Y. Okay, what about this one here? This one now says Y, Control C. So Y is not greater than 14 or Y is not greater than 10. What should be the result in? Y is not greater than 14 and Y is not less than 10. That is 2. 2 also because your seat is 2. Now, all of this, the whole code here, this not, this bigger part here, will return to what? To be 2. False. Oh, shit. Because false, the whole false, this is 2, right? This inner part here is 2. This other second part here is 2. So we now have 2. Okay, now it's as if you want to wrap 2. Okay, this is what I should have done. I should have copied 2, 2. 2 is not equal to 2. That's false. It's like saying, okay, no, this result here is 2. Result here is 2. And the result here is 2 also. So it's not saying that not, it's like saying 2 and 2 is not equal to 2. That would be false. That would be false. So that's the logic behind this. They're saying 2 and not 2 and 2 is not equal to 2. And that's false. So that's one of the easiest way to break this down. So this answer is also be false. False. Oh. So if you could break it down bit by bit, you get your results. So the answer will be false. We know this. Correct. X is less than 3 is false. Y is greater than 14 or Y greater than 10 is false as well. So if you continue working like this, simplifying from inside outward, you end up with false. So that's the truth. So if you continue breaking it down from inside outward, the answer will be false. This is like a good challenge to post online and see people's reaction to it. Now let's solve the final part. Boolean operators with numpy. So before, the operational operators like less than or greater than or equal to work with numpy arrays out of the box. So unfortunately, this is not true for Boolean operators and or and not. To use these operators with numpy, you will need the n numpy logical and numpy logical or and numpy logical not. So here's an example of my house and your house arrays from before to give you an idea. So numpy logical and my house is less than 13 and your house is greater than 15. Now let's use this same way to run our numpy code here. So it's to generate Boolean arrays that answer the following questions. We have our arrays already created, my house and your house. So which area in my house are greater than 18.5 or smaller than 10? My house greater than 18.5. So I want to call on the np dot logical the function. My house greater than or smaller than 10. So logical or that should be all. Open brackets. That says my house greater than 18.5, comma, then or smaller than 10. Oh, or smaller than 10. Oh, to do that, we could just easily use, since it is the or my house, okay, my house smaller than 10. That should give us our results. So which areas are smaller than 11 in both my house and your house? Make sure to wrap both commands in print. Both my house and your house smaller than 11. Both my house and your house. Want to use logical np dot logical and not all this amount. Open bracket. Both my house and your house smaller than 11. Okay, that will be my house less than 11. Your house less than 11 also. So let's see it in now. So let me just copy this first. Let's try it out in Jupyter Notebook. Now let's say my house greater than 18 and my house less than 10. Ooh. NP the logical. Oh, I just spell it very well. Logical or better. And since it should be false, so my house less than or greater than 18 or less than 10. When you go to my house, 18 is less than 18, is not greater than 18.5. This is false. Or is not greater, is not less than 10. So this should be false. So either of the condition is met, is going to return false. You can see my 18 here, 18.5, 18.0, false, less than 10. This is false. So it is the first one that is met that will return. What about this one? Greater than 18.5, 20.2, greater than 18.5, false, greater than 18.5. This is true. So this other one is is less than 10. This is 2 here. But the funny thing that you will know which one is going to return false between either of the equation. Okay, or let's test the second one first. So my house, your house. Oh, let's spell my logical. You can see my house. So we're comparing my house and your house now. This is 11. My house greater than less than 11, and your house less than 11. So this is false, false, false. You can see because this is greater than 11 here. So the two conditions must be met for and. But for all, either of the condition, when either of the condition is met, you are going to get your results. That's interesting. Okay, now let's wrap this up in prints. See our results. Prints. Let's run the code. Oh, let's make my logical pretty well here. Logical. Okay. Can see false, true, false, true. False, true, false, true. Then last one, false, 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 true. False, 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 true. So that's how pretty straightforward it is. So we nailed it there. Correct, perfecto. So that's all about that. So we're moving to if else, if else, if oh, it is originally called if and or if or. That's but we're going to pause here and stop here for today. And and continue on day 12 of the live stream. So we've covered quite a lot. So you can also practice the Boolean structure. It can get confusing at times, just like it's kind of want to be get confused. It's wants to get confusing here also, but they are pretty straightforward. If and operator, if or. Mm. Greater than 80.5, false, or less than 10, which is 2 here. But since this first condition is met, we're going to get our results. Oh, interesting. So I understand the or function better now. All right, so that will be the end of the live stream for today. So we are going to continue from here on day 12. All right, so thanks for staying to the end of this live stream, our Python learning journey with me. So thanks for staying to the end of day 11. I hope to see you on day 12 also. So if you find value in this learning journey, with this 4 way of learning, do well to support the channel by hitting that subscribe button and put on the notification bell. Don't forget to give this video a thumbs up so that it gets recommended also to others or YouTubers out there, to others people looking to upskill themselves in Python. As usual, do make sure to download the files under the YouTube description so you can practice along with me. Without further ado, I'll see you on day 12. Do have a wonderful rest of the day. Bye bye.